The use of innovative projection augmented landscape model technology is bringing science and local knowledge together in a way that facilitates learning about our land. The approach uses simulations of landscape processes projected onto 3D printed landscapes or sand that is shaped to fit the terrain. The projection augmented landscapes look spectacular, like an animated hologram of country. Being multisensory and interactive, the models engage people and generate an environment for learning, teaching, and information sharing, supporting cross-cultural and intergenerational knowledge exchange. This technique is being used to communicate scientific data and spatial information in a way that makes it more accessible and effective for planning and community engagement. This technique has been used extensively with remote communities across Northern Australia to support the two-way learning about fire and land management. By entering fire weather conditions and using scientific information on fuel conditions, we are able to simulate fire spread. This is helping land managers and local communities talk together about managing fire in the vast landscapes of Northern Australia. By painting the 3D landscape with light, we create a dynamic map that allows multiple layers of biophysical and cultural information to be viewed. Using a physical three-dimensional surface helps us understand a landscape and the effect terrain has on landscape processes. These processes are occurring in a 3D world, so they are easier to comprehend when demonstrated in the same 3 dimensions. Anything that requires an understanding of how people and the land interact can be supported through this technology. The impact of different terrain or man-made characteristics of a landscape are right there for the eye to see. For example, how water flows through the landscape. This technology has been used by Charles Darwin University since 2016 for a wide variety of applications around the world, such as supporting Indigenous land claims and fire management planning in Australia, facilitating knowledge exchange with forest communities in Central Africa, and supporting traditional agriculture in Latin America. Importantly, the technology is simple to set up, highly portable, and appropriate for remote contexts. For more information, visit landscapemodels.net.